Well, with this series, the first thing I'm going to do is estimate it. So this would be approximately like having the series. So on the top, the 7 isn't really important. There would be the square root of n squared, so that's just n. And as far as the bottom, the most important thing is the n cubed. That's the most powerful term. And then this is going to be 1 over n squared, and that's a p-series that converges. So not only does that give me the idea that I think it does converge, I'm even going to use that 1 over n squared and use the direct comparison test. So make a direct comparison. Is the square root of n squared plus 7 over n cubed plus 2n squared plus 1 less than or equal to 1 over n squared? If so, that means that it converges. So we can now cross multiply, and if you cross multiply this way, we will get n squared multiplied with the square root of n squared plus 7. And then when you do the other diagonal, it's just going to be the n cubed function times 1. And I don't see any easy way around this. I think we need to do algebra. And the algebra that we need to do is eliminate the square root by squaring both sides. It's always good to practice extra algebra. So on the left side, it's pretty easy. That's just n to the 4th. And then when you square the square root, it gets rid of the square root and gives you just n squared plus 7. But on the other side, we will need to actually multiply n cubed plus 2n squared plus 1 times n cubed plus 2n squared plus 1. So this is a different style of multiplying polynomials. Usually you write them out and use the distributive property, but what I'm doing now is what I learned in 3rd grade. If you have 231 times 74, you multiply like this. You don't use the distributive property. So that's what I'm using right now, that old-fashioned 3rd grade multiplication. So that would mean take the 1 on the bottom and multiply it with each one of the terms. So that means we would have an n cubed times 1 plus a 2n squared plus a 1. Okay, now we're done with the 1. Next, take the 2n squared and multiply it with all of the terms on the top. So when you multiply 2n squared times 1, that's 2n squared, and then you just go ahead and line it up with the n squared down here. And then 2n squared times 2n squared is 4n to the 4th, which I'll just move it over here. And then 2n squared times n cubed is going to be 2n to the 5th. All right, now we just need that last term. So now multiply everything by n cubed. So n cubed times a plus 1 will be plus an n cubed. And then n cubed times the 2n squared is 2n to the 5th. And then finally, n cubed times n cubed is n to the 6th. So when you combine, then combine the 1's, so there's just a plus 1. Combine the n squares, there's 4n squared. Combine the n cubes, that's going to be 2n cubed. And then plus 4n to the 4th, and 4n to the 5th, and an n to the 6th. And keep in mind, all of that was on the right side of the inequality. On the left side of the inequality, we have n to the 6th plus 7n to the 4th. And so we're trying to prove, is n to the 6th plus 7n to the 4th going to be, our inequality was less than or equal to the n to the 6th plus 4n to the 5th plus 4n to the 4th plus 2n cubed plus 4n squared plus 1. And then you could combine all of the terms, move them all to the left. So if you subtract n to the 6th, they will actually cancel. And if you subtract the 7n to the 4th, we finally get is 4n to the 5th minus 3n to the 4th plus 2n cubed plus 4n squared plus 1. Is that bigger than 0? So if you read the inequality in this direction, it's saying that that polynomial is bigger than 0. And then we need to graph it and see if that's true. And I just need to write it down real quick because I am not going to be able to memorize that whole thing while talking to you and entertaining you with my funny math jokes. Okay, so go to y equals, erase the old problem. The new one is 4x is raised to the 5th, and then minus 3x is raised to the 4th. And there's plus 2x is cubed, plus 4x is squared, and then the all-important plus 1. And then take a look at the graph, and where's the graph? Oh, there it is. So the question was saying, is that bigger than 0? And at this point, y equals 1.02. Right here it equals 1, and all the way up here it is bigger than 0. So the answer is it's bigger than 0. So all of that fun algebra actually paid off. This is true for n bigger than or equal to 0. And in case you forgot what we were doing, we were trying to show this inequality is true. And so we proved that this inequality is true, and turns out we can't have n equals 0, so it's true for n bigger than or equal to 1. And then that means that the original series converges.